Good morning, students. In the previous video class, we discussed about how to find the molecular formula and empirical formula by the given of the percentage of the that is percentage composition of the elements. We are discussed in the previous class. In this class, we are going to be discussing about the stoichiometric and stoichiometric calculations. Means that is a stoichiometry. This word is derived from the Greek word. That is a Greek. It is a stoichiometry is derived from the Greek. Means here the stoichion means that is the stoichion means element, and the metron means the measure. This about the meaning of that is stoichiometry. This stoichiometry, the word is derived from the Greek. That is stoichion means element, metron means measure. Yeah. Then what is mean by stoichiometry? Stoichiometry deals with the calculation of masses. That is sometimes it may be volumes. That is the stoichiometry deals with the calculation of masses, sometimes volumes of the reactant and the products which involve in a chemical reaction. Stoichiometry is going to be deals with the calculate ಮಾಡ್ತೀವಿ ಯಾವುದು masses sometimes volumes ಆಗಿರುತ್ತೆ. The masses of the reactants ಮತ್ತೆ products ಯಾವೆಲ್ಲ reactants products involve ಆಗಿರುತ್ತೆ ಒಂದು chemical reaction ಅದರ masses calculation ಮಾಡ್ತೀವಲ್ಲ ಅದೇ stoichiometry ಅಂತ ಕರೀತೀವಿ. We call as a stoichiometry. Stoichiometry deals with that is the calculation of the masses of reactants and products which is involved in a chemical reaction. Now we are going to be considering some equation. That is the chemical equation. That is take example. Let us consider the combustion of methane. Means the combustion of methane which gives that is the carbon dioxide and the water. When the methane, that is the methane means we are going to be taken as the CH4. This on combustion with in the presence of oxygen. In the presence of oxygen is going to be used rise to the carbon dioxide and the water. We should write the balanced chemical equation. We should balance the chemical equation. Just check it out. This already you people are studying in the lower classes. Lower classes study ಮಾಡಿರ್ತೀರಾ ಯಾವ ತರ chemical equation ನ balance ಮಾಡಬೇಕು ಅಂತ. I will check it out. Number of carbon atoms. Here also one. No need of balancing the carbon. Then you can check it out. Oxygen here 2. Then here 2 oxygen. Then hydrogen is here 4. We need to balance the hydrogen. Therefore, we are going to be taken the 2H2O. At that time, the oxygen is here 2. Here the 2 plus 2, 4 oxygen atoms are there. Therefore, we should take the here 2. This is the balanced chemical equation. In this, the CH4, that is methane and the oxygen, O2 are the reactants. These are the reactants and the carbon dioxide and the water. These are the products. ಯಾವುದು reactants? ಇದರಲ್ಲಿ methane ಮತ್ತೆ oxygen reactants ಆಗಿರುತ್ತೆ ಮತ್ತೆ carbon dioxide ಮತ್ತೆ water ಏನಾಗಿರುತ್ತೆ products ಆಗಿರುತ್ತೆ. Products, this I am going to be mentioned, that is methane bracket I am going to be mentioned, that is G. Means this G represents that is the reactants and products are in the gaseous state. Sometimes in some chemical equations we are going to be mentioned the S, means the reactants are products in the solid state. Sometimes we are going to represent the L, means which represent the reactants are products present in the liquid state. This is going to represent that the reactants and products are in the gaseous state. Therefore, I mentioned this are in the G. This are going to be mentioned in the G. This you can observe. That is in front of oxygen molecule, 2 is there. In front of the water molecule, H2O molecule, 2 is there. This 2 are these numbers. That is 2. In this case, nothing is there means it is the presence of 1. Here also 1. This represents the that is the stoichiometric coefficients that we call as a stoichiometric coefficients that we call as a stoichiometric coefficient. This about the chemical equation. We are going to be this we called as a reactant. This we called as a product. That is in the G represented. That is reactants are products which are in the gaseous state. If they are in the solid state, we are going to be mentioned yes. If it is in the liquid state, we are going to be mentioned in the L. Then there is the combustion of methane. Combustion of methane, it gives the carbon dioxide and the water. Means what it represents? That is 1 mole of methane. 1 mole of methane plus 2 moles of oxygen. 2 moles of oxygen gives rise to 1 mole of carbon, 1 mole of carbon dioxide and 2 moles of H2O. 2 moles of H2O. 2 moles of H2O. This is going to represent that 1 mole of CH4, 2 moles of oxygen. That is gives rise to 1 mole of CO2 and 2 moles of water. If suppose if you are written in the molecules, that is 1 molecule of CO2, 1 molecule of CO2, then 2 molecules of oxygen, that is the 1 molecule of CH4, that is methane, 1 molecule of methane and 2 molecules of oxygen gives rise to 1 molecule of carbon dioxide and 2 molecules of water. 2 molecules of water. This is about the in the form if you are going to be taken in the that is the in the molecule. Then if you are going to be taken the gaseous state, that is with the volume, at that time the 22.7 liter of methane, that is 22.7 liter of methane plus that is 45.4 liter of oxygen, that is 45 point of that is 4 liter of oxygen gives rise to that is 22.7 liter of CO2 plus that is 45.4 liter of H2O. Means which represent in the liters. Suppose it is going to be that is going to be in the liters in the gas. If it is going to be taken as the masses, at that time we are going to be taken as 16 gram of CH4. 16 gram of CH4. 16 gram of CH4. Then oxygen. That is 16 plus 16, 32. Then 32 into that is going to be 2 is going to be multiplied. That is 64. That is 64 gram of oxygen gives rise to that is gives rise to carbon dioxide. Yeah, how we are going to be getting that 16? 16 means we are going to be taken that if suppose that is CH4, the molecular mass of the CH4 molar mass is we are going to be taken as carbon is 1 is the atomic mass of the carbon is 12 plus hydrogen, number of hydrogens are 4. Atomic mass of the hydrogen is 1. Therefore, 12 plus 4, we are going to get that 16. That only I written here. 16 gram of CH4. Then 16 gram of oxygen we are going to get. That is 2O2 is there. Then we are going to be written for the O2 means number of atoms is 2. That is 2 into 16. 16 to the 32. 32 into 2, that is 64 gram. We are going to be get that 64 gram. 32. That is, you can write, if you are having any doubt means you can write the 2 into 32 gram. 2 into 32 gram of O2. Then for the carbon dioxide, you can take that carbon dioxide. Number of carbon atoms is 1. 1 into 12 plus 2 into 16. That is 12 plus, that is 32. Totally we are going to be get that 44. Then the 44 gram of CO2 plus H2O. We are going to be taken that 2 into 18 gram of H2O. How we are going to be get that 18 for the water? H2O, that is 1 into 2 into 1 plus 1 into 16. We are going to be get that 2 plus 16, that is 18 gram. We are going to be get that. This from this we can be say that the moles is going to be interconverted. Mass is interconverted. Moles is interconverted into number of molecules. Number of molecules. If this we can be written as, that is the mass is from this equation is interconvertible into moles. Moles is going to be interconverted into number of molecules. Number of molecules. This about the stoichiometry. That is stoichiometry. Now we will solve some problems based on this. How to calculate stoichiometric calculations. That is how to calculate the number of moles if that given in the chemical equation. That we will discuss now. Now we will discuss how to calculate that is the amount of water produced by the combustion of 16 gram of methane. 16 gram of the methane. Yes, that is the combustion of methane. That is combustion of methane means first we should write the balanced chemical equation. Balanced chemical equation means the combustion of methane gives the carbon dioxide and the water. Carbon dioxide and the water. That is suppose the methane, the balanced chemical equation is, that is CH4, that is the gaseous form, then oxygen, the gaseous form is gives rise to carbon dioxide, that is in the gaseous form, plus water. That's what will be in the gaseous form. We should balance the chemical equation. We should balance the chemical equation. Here, what they are given, amount of water produced by the combustion of 16 gram of methane. That also we should represent in the grams. The amount of water produced we should represent in the grams. The combustion of methane of 16 gram of methane. That is combustion of 16 gram of methane. Means here the one thing you should be remember, that is the 16 gram of methane. Methane corresponds to 1 mole. 1 mole means, therefore we can be written as, here you can observe the 1 mole of CH4 produces the 2 moles of H2O. 2 moles of H2O. That is the 2 moles, that is 1 mole of methane produces the 2 moles of water. 2 moles of water. 2 moles of water. Means that is 16. Then you can take that. Suppose that is 2 moles of water is nothing but 2 moles is nothing but that is 2 moles of water is equal to that is 2 into that is water. That is atomic mass of the water is 18. That is we are going to be get that 36 gram. We are going to be that 36 gram. Then otherwise we can take the another by doing the step, one more step, that is the 1 mole of water is equal to 18 gram of H2O. Like that only we take that the 2 moles of water is equal to this. We can write like that also. 2 moles of water is equal to 2 into 18, that is 36 gram. 36 gram means that is 16 gram of methane produces the 36 gram of water. 36 gram of water. This about the answer. Directly they are given in simplified way, simple way. If they are given in a different way, how to calculate will be checked in the next problem. In this question, they are given that how many moles of methane are required to produce the 22 gram of CO2 after combustion. First, we should write the balanced chemical equation. The balanced chemical equation we can be written as is CH4, the combustion of methane gives rise to that is carbon dioxide plus water. This we know that already the 44 gram of that is CO2, 44 gram of CO2 is obtained from 16 gram of CH4. 16 gram of CH4. ಅಂದ್ರೆ ಇಲ್ಲಿ 44 ಗ್ರಾಮ್ ಆಫ್ CO2 obtain ಮಾಡಬೇಕು ಎಷ್ಟಿಂದ 16 ಗ್ರಾಮ್ ಆಫ್ CH4 ಇಂದ. Means it indicates that bracket ಅಲ್ಲಿ that is 1 mole of CO2 is obtained from 1 mole of CH4. Therefore, we can be written as that is what they are asking. They are asking how many moles of methane are required to produce the 22 gram of CO2. Means the 1 mole of CO2, that is 1 mole of CO2 produces, that is 1 mole of CO2 obtained that is 1 mole of CO2 is going to be obtained from the 16 gram of CH4, that is 1 mole of CH4. Therefore, this we can be written as that is the 16 gram. gram produces the 16 gram of methane, use the 44 gram of CO2, then x moles, that is one, otherwise instead of 16 gram you can be written directly 1 mole of methane, use the that is 44 gram of CO2, then x mole, we don't know, that's right, x mole of methane gives rise to, that is 22 gram of, that is CO2. Then cross multiply the x into 44, that is gram of CO2 is equal to, that is 1 into 22 gram of CO2. Then we are going to be get that x is equal to 22 gram of CO2 divided by, that is 44 gram of CO2. Then we are going to be get that is x is equal to 0.5. We are going to be gram of, that is moles of CO2. That is we are going to be get that the x is equal to 0.5. Then we can say that the 0.5 mole of methane are required to produce 22 gram of CO2. ಅಂದ್ರೆ ಇಲ್ಲಿ ಏನು ಹೇಳಿದ್ರೆ ಫಸ್ಟ್ ನಾವು ಬ್ಯಾಲೆನ್ಸ್ ಈಕ್ವೇಷನ್ ಮಾಡ್ಕೋಬೇಕು. 44 gram of CO2 is obtained from the 16 gram of the CH4. Means it is nothing but 44 gram is 1 mole of CO2. 16 gram of CH4 means it is 1 mole of CH4. Then 1 mole of methane gives the 44 gram of CO2. Then x mole of methane gives the 22 gram of the CO2. Then this cross multiplication we get that is x into 44 gram of CO2 is equal to 1 into 22 gram of CO2. That is going to be cancelling ones, then 2s are 1 by 2 is nothing but 0.5. That is 0.5 moles of, that is methane. 0.5 moles of methane is required to produce the 22 gram of the, that is CO2. 22 gram of this. Let's about the products.